Okay, so let's talk about the AMD timeline here. I mean, it wasn't so long ago that AMD introduced this like 7 nanometer graphics processing between CPUs and GPUs. Like that was 2018, and we've ridden that wave for a long time. And certainly 7 nanometers has its perks. In fact, I feel like Intel can't keep up. Like Intel is floundering right now, and they don't know what to do. If you look at spec sheets that are out there all over the internet about comparing Intel CPUs versus AMD CPUs, it's really not that sort of a comparison, right? You have, the first 6 or 8 lines are just all AMD CPUs. The next line is maybe an Intel, followed by 5 or 6 more AMD CPUs that are almost equivalent to the Intel. So, yeah, concerned Intel. What are you guys doing to fix this? Okay, jumping back to the AMD timeline here. So, starting from November and kind of working our way forward, we saw the Zen 1, the Zen 2, which was a massive improvement on the Zen 1 as far as floating processes from one chiplet to the next chiplet. And then Zen 2 to Zen 3, again, I think the affordability became a factor, like if in theory, before scalpers existed, right? Or, I mean, they've always existed, but before they really hit full swing here. The idea between like the 5000 series was that it was actually more affordable than say like the 3900 series, right? So we saw affordability until COVID and the chip shortage and so on, but hey, it's all there. And then kind of work on our way forward to the 5000 Zen 3 series, which are just a super hit in the market. I mean, like everyone wants a 5950X. Let's just be realistic. Like that's probably the best CPU you can buy for the buck, and the performance, and it's just an amazing CPU. Whether you're, someone in CAD or engineering, or you're a streamer, or you're a video editor, like it's totally applicable to the whole crowd. In fact, I can think of only a few cases where you might want to jump to a Threadripper Pro, say like if you're really heavy in simulation or you're a very heavy editor, right? Then you might be able to justify the cost of those larger CPUs with bonus improvements and extra RAM and so forth. So this is the timeline. This is what we know now. But what we're here today, what we're here to talk about today, is how AMD is going to improve on this with the new Zen 4 series architecture. The 5 nanometer Zen 4 series architecture. Let's be realistic. We all want the 5 nanometer. Okay, so let's compare Zen 2 to Zen 3 for a second, just so that we have a decent understanding about the improvements. And don't forget, Zen 1 to Zen 2 was massive. But comparing Zen 2 to Zen 3, essentially 4 cores communicated with one set of cache, while the other 4 cores could communicate with the other set of the cache, but at no point in time could, like 4 adjacent cores, talk to its adjacent cache. So this was a small problem in that they had to float the processes essentially to the other cores, which means it was sort of a intensive process, right? It wasn't as efficient as it could be. And so when we look at the layout of the chiplet now in the Zen 3 CPUs, the cache and the cores are all combined. So floating processes and floating threads, floating information from one chiplet to the next essentially isn't an issue. This was a significant enhancement to the way Windows would actually utilize multi-core, right? Multi-thread. All the while, what Zen 3 also allowed us to do is to take advantage of, say, applications that are mainly single-threaded, where mostly only one core is pegged. Like let's just say SolidWorks or various other applications that are not like multi-thread aware per se, and we were able to see improvements, 10 to 20% improvements just based off this from Zen 2 to Zen 3 improvement. So that was nice. So moving in the direction of just the normal logical upgrade path, we see that the chiplets in the Threadripper Pro series are slightly smaller than that in the Zen 3, like AM4 Plus, the 5950X, and so on. So we would expect to also see that improvement trickle over to the Zen 4 architecture, right? So instead of the chiplet being, the footprint that you see here, like on Zen 3, on the Zen 4 side, you can see what that chiplet might look like going forward. So with the same amount of cache, the same amount of cores, we have a smaller footprint. So this leads us to our next discussion, actually. And I've modeled these up in SolidWorks so we can take a look at them 3D. So here we go. Let's jump into SolidWorks. All right, crew. So I wanted to expand what our visual was on exactly what these CPUs have inside of them so that we can have that discussion about chiplets and high-speed I/O and all that. So what I have here on the screen is actually a Cad model of the current AMD Ryzen Zen 3 series. And, at a quick glance, it just looks like a normal CPU. But what we really want to look at here is the stuff on the inside. So what we have are the 2 chiplets and then the high-speed I/O. And this was I should say from Zen 1 to Zen 2 was probably the biggest improvement, which involved, incorporating these 2 chiplets and the high-speed I/O. With the jump between Zen 1 and Zen 2 multitasking for like window processes was like a massive improvement. Like when we're comparing to like the NUMA cores versus how we float processes now from like one chiplet to the next chiplet through the high-speed I/O, right? So from Zen 1 to Zen 2, massive improvement. From Zen 2 to Zen 3, improvement on the cache. And then also how those processes are managed. And this kind of brings us up to our current understanding of what AMD has in the pipeline because, hey, these chips are out, right? But this is what these chips look like. It's 2 chiplets, 1 high-speed I/O. So with that kind of in mind, what I've gone and done is created like the next 2 releases of the AMD Zen 4 CPUs, which are highly anticipated, and that 5 nanometer capability, manufacturing capability, is a huge feat for the company. So when they actually make that a thing, when they actually make that a thing that they can mass produce, right? This is what we're expected to see here. So I've gone through and made 2 variants of this. Now, this is largely speculation, but I'm just applying logic and normal, like linear escalation as far as CPUs go. But let's take a look at the Zen 4. So the Zen 4 version 1 is kind of what I had in mind. It's going to look really similar to the Zen 3. It's going to have the same socket, the same AM4 plus socket. But one of the biggest differences is going to be the size of the chiplets. So leveraging what AMD solved in the Threadripper series and the Threadripper Pro series of CPUs was that these chiplets could be reduced in size drastically. So we're looking to save about 30% on the overall footprint of these chiplets, and continue to have the same I/O speed. So with that in mind, my thought is that, hey, look, when AMD releases a 5 nanometer CPU, everyone's going to jump on the wagon. So they really don't need to do a whole lot of improvement to how many chiplets are on the chip or how many high-speed I/O footprints there are, right? So this makes sense from like a business standpoint, right? Let's get the 5 nanometer down, and then let's use existing technology, add it to it, and release our 5 nanometer chip. Totally on board with that. I think this is going to sell amazingly well, especially since it's 5 nanometers, right? So then where do we go from there? Well, again, leveraging that same technology from the Threadripper Pro series, having a smaller chiplet means that on version 2, they could possibly increase the threads or just the global core count on the CPU in the same socket, right? Not a different socket, the same socket, by adding 2 more chiplets. So instead of having just the 2 chiplets, we would have now 4 chiplets because they can fit in the footprint. Thus having, potentially up to 32 cores, 64 threads, of processing power, right? Same size, high speed input output, but more processing power. So I reckon that this will be the version 2 series of the Zen 4, and this is going to be an absolute powerhouse if they can figure out the thermal loading. But that's kind of the idea behind going to 5 nanometer, right? So I prepared this spec sheet just real quick so that we can take a look at what I think AMD is going to be offering down the road with the new Zen 4 CPU processors. Now, it's hard to say, it's like, I don't work for AMD, I don't predict the future, but I'm just applying, like, the linear sort of logical thinking as they've progressed from the Zen 1, Zen 2, Zen 3, and then now the future Zen 4 series of what we might expect. And it's a rather entertaining journey, I think, so far. So let's take a look at some of the specs here. So I've organized this into 2 categories, the Zen 4 version 1 and the Zen 4 version 2, kind of illustrating the beginning of the 5 nanometer realm, and then how they plan on improving upon that almost right away with current technology that they already have. So I kind of labeled these the 6000 series CPUs, again, just escalating the naming nomenclature that AMD has provided us up until now. So we'll call this the 6000 series. And I think that we are in for a treat because I think the AM4 socket is here to stay for a while. Now, I've kind of expanded on this internally and said, okay, if not the AM4, then maybe an AM4 Plus? Again, like the AM3, AM3 Plus, and so on. But in my personal opinion, I would put money on the AM4 socket as being the new Zen 4 delivery socket. If it's not the AM4 Plus, it's going to be something brand new. So it's not something existing. But this is my best hypothesis as to what socket they're going to run. So moving on to chiplets. Now, we talked about how the chiplet size was going to change so that we could put, essentially more chiplets on one footprint. So the first release of the Zen 4 processors at 5 nanometers is actually still going to be just the 2 chiplets, right? With the 1 high-speed I/O. Now, I think this is just a good business plan, right? Everyone's going to jump on the 5 nanometer wagon, and they're not going to care about chiplets because they just want a 5 nanometer CPU. Now, if AMD actually figures out how to mass produce 5 nanometer GPU or CPUs rather, then we are all in for a treat, right? I'm sure they already have now. It's just the process of making that manufacturability scalable, right? So continuing on to this series, we have a 6600X, a 3800X, a 6900X, and a 6950X. I might have said 30 in there. I don't know why I said 30. But anyway, it's all 6 series. We have the 6-core 12-thread at 4.7 gigahertz with 55 watts of TDP. And then jumping over to the 6800X, we're going to see 8-core 16-thread 4.9 gigahertz with 72 watts. Again, the lower wattage actually makes sense. That's why we're moving to 5 nanometers, right? Then jumping on to the 6900X, we have 12-core 24 threads, 5 gigahertz boost, with the same cache technology that we would see in the Zen 3 5900 series at 72 watts as opposed to 105 watts. And then scaling that up one more time with the 6950X, 16 cores, 32 threads at 5.1 gigahertz boost, again with the same cache that we see in the 5900 series, 5950 series, but again with a lesser wattage at 75 watts TDP. Now, this is where it gets interesting. So, jumping into the version 2 of the Zen 4, as I think there's room for improvement, and I think AMD knows this, and they're going to leverage the snot out of this, right? Just the fact that they've been able to manufacture a smaller chiplet on the Threadripper and the Threadripper Pro series of CPUs means that they can take that technology and easily just implant it into the Zen 4 CPUs. So this is where things get interesting. You saw my CAD model about what that looks like. We can now stack 4 of the chiplets onto the same CPU footprint, the same socket size, and therefore double the amount of cores that we have on the CPU. So with that in mind, then we can jump to the version 2 series of CPUs, which again, I just totally looked at the naming nomenclature of AMD and kind of just interpolated that data upwards to the 6000 series. You might have a different take on this. That's cool. Put it in the comments, but otherwise, this is just my best guess. So we have the 6655X, which seems odd to say, and then the 6855X, again in that same category. But I put asterisks on both of those, and it doesn't make sense for AMD to actually manufacture these because this is overlapping inventory, essentially. You can see by the asterisk there at the bottom, it says, hey, it doesn't really make sense to manufacture these because then customers would just go buy a 6900X or a 6950X to fit these, like, you know, the same kind of category, the same kind of bucket. So with that in mind, not likely to make those two variants, but the next two are highly likely. So we have the 6955X, which is a 24-core, 48-thread, essentially doubling the 6900, with a slightly lower boost clock because, again, my prediction is that there's like a thermal barrier there, right? So you might not get as high as a clock speed, but you're going to get a whole lot more cores with just a little bit more power requirement than 90 watt TDP rather. And then to their flagship model now for the Gen 2s would be the 6995X, 32 cores, 64 threads, 4.7 gigahertz. The same cache that we see, the same cache improvement that we saw on the Zen 3 series. And then with essentially the effective watt of what a 5950 is, but with significantly more processing power. So, you know, if we reflect on this for a second, you know, these sort of specs boast a huge improvement from the AMD CPU series. And again, Intel is floundering. I mean, they're dead in the water. If you look at the spec sheets for CPUs, it's hard to justify an Intel CPU other than the fact that you can get them right now, right? Because the scalpers aren't buying those CPUs because, well, they're just not as good, right? So, you know, if you look at the spec sheets, you'll see 6 AMD CPUs, and you'll see, you know, Intel's flagship. Then you'll see another 5 or 6 AMD CPUs that almost nearly match the Intel flagship model, right? So, you know, AMD is just killing it right now. And this would be a way for AMD rather to kick Intel while they're down. This would be like a finishing blow. And for the first time ever, we've seen, you know, AMD CPUs over these last couple of years spike to prices higher than that of Intel CPUs. And it always used to be the inverse. It always used to be, hey, I'll pay more for an Intel because it runs cooler, or because it processes faster, or because et cetera, et cetera, et cetera, right? I'll buy a Xeon for ECC, and so on. But now those aren't really the things that we're talking about anymore, right? It's all about the AMD 5000 series CPUs, and now soon to be, hopefully, the 6000 series 5nm CPUs. So with some of these kind of things in mind, right? Again, these are speculated specs, right? Interpolating data and then just kind of merging all of AMD's technology together. You know, this seems like a logical linear approach. I mean, you tell me otherwise. Put it in the comments. Let me know what you think. You know, where do you see these differences, and how do you see them making a difference? I just said the same thing twice, but that doesn't matter because you'll put it in chat, I'm sure. They essentially take what now we know is the processing power of a Threadripper and a massive socket size and reduce it down to an AM4 plus size socket with all the same power. Like, this would just be amazing. Now, I look at these numbers and I'm thinking like, okay, these gigahertz ratings are definitely estimates, but wouldn't it be nice? 64 cores, 4.7 gigahertz. I mean, come on, we can dream. All right, so I keep on stealing from the Threadripper Pros, I know. But again, this just makes sense. AMD's put a lot of time and logic into, you know, essentially security layers on their Threadripper Pros. There's no reason why they shouldn't pass that along to their Zen 4s. So here, let's take a look at the AMD Pro security. So security, I think, is a big thing for all of us, especially those inside of design or manufacturing, anyone with, you know, IP, intellectual property, that they want to protect. So AMD has developed a security, you know, a security blanket, if you will, over their CPUs that, you know, is actually built in at the silicon level and kind of scaled up. Now, it's a whole laundry list of things, but the two most important things I think on this list are one, full memory encryption, and I should say full memory encryption without any negative externalities. So we're not sacrificing performance for encryption, which I think is a big plus. And then two, the limitation, I suppose, of outside users gaining access to information on your computer from like a cold boot, so cold boot security. Now, this only makes sense to keep trickling this sort of technology into processors. Also, it gives them leverage over Intel processors, I think, in a big way. So I would expect to see this technology show up in the Zen 4 architecture as well. I mean, it only makes sense. All right, so the last thing to really talk about here is pricing. And again, this is just completely speculated. But guys, who the heck knows, right? With the way things are going right now, scalpers, not being able to buy things at MSRP, like, I don't know what's going to happen with pricing. Like, is AMD going to reassess the pricing level of the Zen 4s? Well, it would only make sense if they made it more expensive. Seeing how it's like a 5 nanometer CPU, they kind of have the right to increase the price a little bit. For the first time, we're seeing, AMD processors that are drastically more expensive than Intel. And in the past, that was always like, well, it's an Intel processor. Of course I'll pay more for that. More power, better performance, lower temperature, etc. But now, the turntables. Just kidding, that was a Michael Scott quote. The tables have turned, right? Now we're seeing this total inverse in pricing structure. So it's really hard to say exactly how this is going to be priced and how it's going to fit, for everyone in the market. I suspect similar pricing to the Zen 3 series, but like, who can see the future, right? Okay, so just kidding. But I hope you liked this look at what I think the new AMD Zen 4 processors are going to hold for us. And it looks super promising. I'm holding out right now for those Zen 4 5 nanometer CPUs. I just can't wait until I get my hands on one so I can test it, run some simulations, do some renderings, pair it with my RTX A6000. That should be a good matchup. So with that being said, if you enjoyed this conversational video, please give it the thumbs up and the like. I definitely appreciate your support. And hey, until next time, fight on.